For number 6, we're going to determine the critical value for a left-tailed test. And we want our significance level alpha to be 0.10. So if you look at the standard normal distribution table, you're looking for the probability in the table. We're looking for 0.10. And if you go to negative 1.28, that's as close as we can get to 0.10. And that's actually our answer for our critical value. Now you can also, some of the more common ones show up in the textbook on page A12 at the back of the textbook. There's hypothesis testing critical values, and some of the levels of significance are listed here. And notice how the left-tailed and right-tailed values are the same numbers, just opposite sign. For number 7, we're going to test the hypothesis using the classical approach and the p-value approach. For both of these methods, if you look on page 487 of the textbook, you'll see you need to calculate the test statistic. And it gives you the formula. It's the same for both methods. So I'm going to jump into Excel. And here I've just copied down all the information from the problem. And giving the information about our sample, we can figure out what our sample proportion was, which is just 44%. So that is below our null hypothesis, and we'll test now with the classical and the p-value approach whether it's far enough below for us to reject the null hypothesis and accept the alternative. So calculate the test statistic using that formula from the textbook. And then for the classical approach, we need to see which critical value is associated with a 0.1 level of significance. So you can have Excel do that. If you type in 0.1 to this formula, it gives you back the critical value that has just 10% in the left-hand tail. So we get this critical value. And since our test statistic was even further to the left than the critical value, we're going to go ahead and reject the null hypothesis. With the p-value approach, we actually look at our test statistic and plug it into this formula in Excel, and it gives the probability of this outcome, or one even further to the left, of occurring. And the probability of being at this level or even further in the left-hand tail is less than 10%. It's about 7%. So again, we're going to reject the null hypothesis using the p-value approach. For number 8, we had a large sample of patients taking a prescription drug, and many of them complained of flu-like symptoms. Now the industry standard for this type of drug is just 1.5% of patients complaining of flu-like symptoms, so that's our null hypothesis. And we want to test whether this drug has more than 1.5% of people complaining of flu-like symptoms. So our alternative hypothesis is that more than 1.5% will have flu-like symptoms. So we're going to find the p-value and see whether to reject the null hypothesis or not. So here's the information from the problem. This many people in our study, this many had flu-like symptoms. So for our sample proportion comes out to about 2.71% of people complaining of flu-like symptoms. So that is bigger than our null hypothesis, so we need to test now whether it's significantly enough bigger that we're going to go ahead and reject the null hypothesis and assume that this is true. And here's our level of significance given in the problem. So calculate the test statistic. Again, the formula is on the book, page 487. And then with your test statistic, I'm going to use Excel here. Plug it into this formula, and Excel gives the probability of from this value or to the left, the probability of that. Now, since we're doing a greater than right-hand tail test, we actually need to do 1 minus the answer we get back, and that'll give us the right-hand tail then. Excel always gives the left-hand tail. So you do 1 minus and we get the value for the right-hand tail, which is our p-value. And so what we take away from that is that if our null hypothesis was actually true, the likelihood that we would get a sample with this many people or more having flu-like symptoms as a side effect is less than 2% likely. So it's very unlikely that we'd get a sample like the one we did if the null hypothesis was true. And we had set our level of significance at 10%. Our p-value is below 2%. So we're going to go ahead and reject the null hypothesis. Number 9, we have a satisfaction rate. And then we are surveying a new sample of people. And we're going to see if that satisfaction rate has changed in any way. So our null hypothesis is that it's the same. And the alternative is that it's not the same. It's either gone up or down. And we're going to solve this one by creating a 99% confidence interval. So if you recall back on page 432 how to create a confidence interval. So jumping into Excel, we have our hypothesis. Here's our sample information. And so our sample proportion comes out to just over 42%. So it's not exactly 42, and now we need to test whether it's far enough away from 42% for us to reject our null hypothesis. Our level of significance plays into the confidence interval for that z-value part, our critical value here. And so for 99%, it comes out to 2.575, and plug in the rest of your numbers, and you get this margin of error for your confidence interval. So take your sample proportion, subtract the margin of error to get the lower bound, and then add the margin of error to get the upper bound, and there's your confidence interval. And for our hypothesis test, since our null hypothesis is within this interval, we would say there's not enough information for us to reject the null hypothesis. In terms of this particular problem, it would mean there is insufficient evidence for us to assume that the satisfaction rate has changed. For number 10, we have a survey where 45% of people said they talked to their pets on the answering machine or telephone. And there's someone who doesn't believe that result. They think it's a little bit too high, so they want to collect a random sample and then see if they can show that this number is in fact too high. So the null hypothesis is that this is the correct value, and the alternative hypothesis is going to be that the actual proportion is less than that value. And here's the level of significance we're looking for. So we're going to use the p-value approach, jump into Excel. Here's the data we have from our sample. So our sample proportion would come out to 36%. So that is less than the stated 45%. Now we need to see if it's far enough less that we can reject the null hypothesis. So using the p-value approach, we need to find the test statistic. So we'll plug these values into Excel. So our test statistic, calculate it, comes out. And then we're going to use Excel again to find the probability of drawing a sample with these results or even farther to the left. And we use that using this formula here in Excel, plug in our test statistic, and our p-value comes out to just over 1%. Our level of significance was 10%, and since our p-value is less than that, we are going to reject the null hypothesis. It's very unlikely that if this is true, we would have got a sample proportion like this. So we reject the null hypothesis.